guys. Okay, we're finishing the example that we started in class. Okay, Omar has a piece of rope. He ties a knot in the rope and measures the new length of the rope. He then repeats this process several times. Some of the data collected are listed in the table below. So let's say we wanted to graph each of these data points, right? You don't need to know this. Actually, let's put it in our calculator. Let's graph these, okay? You don't need to know this. I'm just kind of explaining what is visually occurring here, okay? So I have my data in the X column and my data in the Y column, okay? So if I wanted to graph this, right? This is what these data points look like on a graph. Okay, and then if I wanted to draw a line of best fit that passes through as many data points as possible, I would draw something that looks like this. And this would be the linear regression equation, right? This is the line of best fit. This is the line that passes through the most data points. You are going to calculate this and write the equation of this line using your calculator. Okay, so we have our data entered in the X column, we have our data entered in the Y column. Now we are going to write the linear regression equation, which will look just like this. Y equals mx plus b, where m is the slope of the line of best fit and b is the y-intercept of the line of best fit.
You're way above me, way above me.
So now what we're going to do is look on our output over here, right? And we've got our slope is negative 8.5. So let's put that in there, right? We've got y equals negative 8.5x, and then the y-intercept is going to be b, which is 99.2 plus 99.2. Have we rounded to the nearest tenth? We have. So this looks great. This is our linear regression equation. And if you'll notice, right, on the one that we graphed on here, I mean, you don't need to know how to do this on your calculator, but I just wanted to show you. That was exactly the equation of the line of best fit. It was negative 8.5x plus 99.2. Okay, so we've written our linear regression equation. Explain what the y-intercept means in the context of the problem. So the y-intercept is 99.2. So that means that the initial or the starting length of the rope had to be 99.2 centimeters. Hold on, let me move this over so I can put in the centimeters. And then explain what the slope means in the context of the problem. It means for every knot that Omar ties, the rope is shortened. Why is it shortened? Because the slope is negative, right? Negative slope, so the rope's getting shorter. The rope is shortened by 8.5 centimeters. State the correlation coefficient to the nearest thousandth. So that means we're going to be looking for R. Let's look on here. And we want R. Remember, we don't want R squared. R right here, negative 0.997, negative 997. And then I'm supposed to be rounding to the nearest thousandth. Remember, this is the ones place. This is the tenths place. This is the hundredths place. This is the thousandths place. We have, in fact, rounded to the thousandths place, so we're all set. State the correlation coefficient. R equals negative 0.997. Now, explain what the correlation coefficient means with regard to the context of this situation. So if we're explaining the correlation coefficient in the context of the situation, that means we're going to have to mention both variables. And we're going to have to use words to explain. Okay, so the correlation coefficient is is negative 0.997. So that is a negative number, and it's really close to negative 1. So that means that the linear regression equation is a good fit for the data because negative 0.997 is very close actually, to negative 1.